We are going to study solstices and equinoxes in this video. Direct questions have been asked from this topic in recent years UPSC prelims. Understanding the entire phenomena is essential to answer any question from these topics. By the end of this video, you will be able to answer these or any other questions from this topic. Earth moves around Sun in an elliptical orbit. The orbit is not a perfect circle, but oval-shaped. Hence, it is called an elliptical orbit. But there is one more notable feature. Sun is not at the center of this ellipse. Sun is slightly away from the center. Hence, at one point, Earth comes closest to the Sun, as much as 147 million kilometers. At another point exactly opposite, Sun is as far as 152 million kilometers. This closest point is called perihelion, and the farthest point is called aphelion. This movement of Earth around Sun in this orbit is called revolution of Earth. Imagine Earth was stationary on its axis, but only revolved around Sun in elliptical orbit. If American continents had faced Sun, it would always have been a day in Americas with broad daylight. The other side of the Earth would always have had night with perennial darkness. But we know this is not the case. We have day followed by night in all places. This is because Earth rotates on its axis while revolving around the Sun. This rotation is responsible for day and night. In this model, you can see Earth's rotational axis is perpendicular to the ecliptic plane. Ecliptic plane is the imaginary plane that contains both Sun and Earth's orbit. Earth's axis in our model here makes 90 degree with the ecliptic plane. In such cases, you can expect nearly 12 hours of day and 12 hours of night everywhere on Earth. But this is not the case. Our model is still not accurate, because we know that lengths of day and night are not same throughout the year. In summer, it will not be dark even at 7 pm. But in winter, by 5:30 pm, it will be dark outside. If you are a resident of Delhi in second half of June, your day is nearly 14 hours long and night darkness is only for about 10 hours. Similarly, in second half of December, day is only 10 hours and night is nearly 14 hours long. This occurs because Earth's axis is not perpendicular to ecliptic plane, but is tilted by 66.5 degrees to the plane. That means 23.5 degree tilt from the perpendicular plane. This is exactly the reason for seasonal variation in length of day and night. There is one very special nature of this tilt. It remains the same throughout the revolution. Imagine Earth revolved like this around Sun. Direction of its tilt continuously changing. This is not the case with Earth. Direction of Earth's axis remains unchanged throughout the revolution. This is called axial parallelism. Because of this, for some part of the year, northern hemisphere faces towards the Sun, and for some part, southern hemisphere faces towards the Sun. When northern hemisphere is tilted towards Sun, length of days are longer and nights are shorter. Longer days mean more heat transferred to northern hemisphere compared to southern hemisphere. This is summer in northern hemisphere. At the same time, it is winter in southern hemisphere because it is tilted away from the Sun. Shorter days and longer nights result in less heat reception from Sun and results in winter. Before jumping into equinoxes and solstices, there is one more concept you need to understand. Imagine you have vertical poles installed at different places on Earth like this. From Earth, Sun appears small even though Sun is gigantic compared to size of Earth or any other planet. Because of great distance, Sun appears like a disk and point source of light. Sun rays hit Earth at different angles at different places. Because of this, all poles cast a shadow except at one location. At this one location, Sun rays are parallel to the pole and no shadow occurs. Sun appears to be directly overhead from this point. This point on Earth is called subsolar point where Sun is directly overhead. Here you can see at this given time, Sun is directly above equator at 0 degree. This point continuously changes because of Earth's tilt and its revolution around Sun. Now let us get into solstices. When northern hemisphere is tilted towards sun, subsolar point is in northern hemisphere. Days are longer than nights. It is beginning of summer. As days progress from March, April and May, this subsolar point moves northward in northern hemisphere a little by little every day. When the date is 21st June, this subsolar point reaches as north as 23.5 degrees. Because of tilt, revolution and axial parallelism, this subsolar point where sun appears directly overhead does not go any more northwards from this limit. This 23.5 degree is the northernmost limit of this apparent journey of subsolar point. We drew a parallel at this limit and called it Tropic of Cancer. Tropic means turning around, like U-turn, hence the name. After this limit, this subsolar point takes a U-turn and starts moving towards southern side. All these days so far, sun appeared to move northward a little by little every day. But on the day of U-turn, it takes a little time and sun appears to be standing still on this day of June 21st. So this day is called solstice, which means sun standing still. And since it is happening at peak of summer in northern hemisphere, it is called summer solstice. Let us see what is happening on other parts of globe on this date. Sun is at northernmost limit. Days are the longest in northern hemisphere and nights are the shortest. Areas inside of Arctic Circle are lit up for whole 24 hours. There is no night. This area inside Arctic Circle in summer is popularly known as Land of the Midnight Sun. Nowhere inside the area of circle, sun sets in whole 24 hours. See this video from a place called Lofoten Island in Norway, which is inside of Arctic Circle. This is midnight of June 21st. You can see sun throughout the night. This 24 hours daylight, at least for one day in a year, happens only in areas north of 66.5 degree latitude. Areas outside of this will have sun below the horizon every night. On 21st June, for a person at Arctic Circle, it is day all 24 hours. For a person at North Pole and around also, it is day all 24 hours. And it is same for anyone in between. Now let us see what happens for next 3 months from June 21st summer solstice. Subsolar point starts moving southwards a little by little every day. The length of day starts decreasing a little by little from peak of summer solstice. On 23rd September, this subsolar point reaches equator. The imaginary line that separates day and night is called circle of illumination, and it passes through both north and south poles on 23rd September. On this day, all places on earth have equal length of day and night. Hence, this day is called equinox. It literally means equal night. After summer and before winter, the season is called autumn. And hence, this September 23rd event is known as autumnal equinox. All these days, sun was visible above horizon at North Pole. After this day, sun starts setting and will be below horizon for next 6 months. Other parts of Arctic Circle will have shortening days and increasing lengths of nights. It is same for other parts of Northern Hemisphere. Days shorten and nights lengthen. Subsolar point reaches peak south of 23.5 degrees on December 22nd. It does not go any further south. This limit is called Tropic of Capricorn. Sun appears to stand still for a brief duration here. Hence it is known as winter solstice. On this day, it is 24 hours daylight inside Antarctic Circle and 24 hours night inside of whole Arctic Circle. It is important to note that it is winter for us in Northern Hemisphere. Hence we call December 22nd as winter solstice. But for people of Southern Hemisphere, it is summer. Their length of days increasing and night lengths decreasing when subsolar point moves from equator to Tropic of Capricorn. So for them, our winter solstice is their summer solstice. And when our summer solstice was going on June 21st, it was their winter solstice. Likewise, when entire Arctic Circle had 24 hours of daylight on June 21st, Entire Antarctic Circle had night for all 24 hours. When sun starts setting for next 6 months from September 23rd equinox at North Pole, sun starts rising and above horizon in South Pole for next 6 months. Basically, the events in northern and southern hemisphere are similar but opposite. After winter solstice, sun makes U-turn and starts moving northwards. The subsolar point reaches equator on 21st March. It is similar to earlier and marked by equal lengths of day and night. Since season after winter and before summer is known as spring, March 21st is known as spring equinox or vernal equinox. Now, circle of illumination again passes through both north and south poles. Sun will rise at North Pole and set at South Pole after this date. Sun will be above horizon for next 6 months at North Pole and below horizon at South Pole, and the whole process repeats. These dates slightly change sometimes. Take a screenshot of this table. Watch our next upcoming video about twilight and dawn. They impact visibility of sun and daylight. Now coming back to the questions we showed in the beginning, we are sure you will be able to answer them after watching this video for 2-3 times. Thank you for watching and subscribe to our channel Clarity of Concept.